In the process of data preparation for machine learning tasks, an always important aspect is determining its type. It's common to work with data that has a numerical value type, sizes in centimeters or degrees of temperature. Interpretation bracket ito for example. But in complex data tables, which gather many different characteristics, just as we have seen that it's very likely to have missing data that we need to handle, some columns of the table may contain data known as categorical. Categorical data represent qualitative characteristics or attributes of those data, while numerical data express quantities and allow us to perform mathematical operation with them, which we cannot do with categorical data that we can classify or label. The categorical data is further divided into two subtypes, nominal and ordinal. Nominal data doesn't have its own hierarchical order. A good example would be t-shirt colors. Ordinal data does have a hierarchical order, although they don't represent exact quantities. The sizes of those same t-shirts would be a good example. XL is larger than L and L is larger than M. The color of the t-shirts would be an example of nominal categorical data, and their sizes an example of ordinal categorical data. The prices of the t-shirts or the quantities available by color or size would be examples of numerical data. We're going to explore different techniques for handling this type of categorical data. But first, like in the examples in the previous videos with missing values, let's create a new data frame to illustrate the problem well. This is the code where we create a pandas data frame with 4 columns. One of them contains a nominal feature, color, another an ordinal feature, size, and a third a numerical feature, price. The class labels, in the case that we are creating a dataset for a machine learning task, are stored in the last column. The class labels we use here are nominal categorical, although depending on the algorithms, they could also be ordinal categorical or numerical. One of the common tasks in preparing data for machine learning tasks is the assignment of features that contain ordinal data so they can be correctly interpreted by learning algorithms, for which we need to convert the categorical string values into numerical values. Hence the importance of a method like map. In this case, a specific method from pandas to work with data frames. Although Python also has a more generic map method that allows you to apply a specific function to all elements in an iterable, we don't have a function that automatically performs this assignment of ordinal categorical values to numerical values, as they can vary greatly from one to another. Here we have the ordinal categorical value size that classifies t-shirt sizes into 3 categories: XL, L, and M. What we have to manually define is an assignment, what is usually called a mapping in English, of a numerical value to each of the sizes. Simplifying the previous example, let's say we assign the numerical differences between the sizes by increasing the value by 1 for each size. XL would be equal to L plus 1, which in turn would be equal to M plus 2. We could keep adding sizes up or down by simply changing the assignment. To carry out this assignment in this code, we use the pandas map method, which replaces the values of a series based on a dictionary that, as we see here, we pass as an argument to the method. This argument could also be a series or the result of calling a function. But here we pass directly a dictionary that assigns a value from a series to each size. Number. This way we turn clothing sizes XL, L, and M into numeric values 3, 2, and 1 using a dictionary. If there are values not found in the dictionary, they will become none, which we can then handle using the missing value techniques we have already discussed. This map method is widely used to convert categorical data into numerical data, making analysis easier in machine learning models. Remember, by now it should be clear that in machine learning, especially with neural networks, it's crucial that all input data be numerical. Neural networks operate by performing complex mathematical operations, such as matrix multiplications and weighted sums, which makes it mandatory to convert all inputs into numerical types. So any categorical data, whether ordinal or nominal, must be converted to a numerical format before being used in training. Hence the importance of this map method. If we want to convert this data, which are now numerical, back to their original string form as categorical ordinal values, we can define what is called an inverse mapping dictionary. Once the dictionary is inverted, we can pass it back to the map method of pandas for the specific column of the data frame we are inverting. Here we see the code where we do it using a dictionary comprehension, which allows us to invert the keys and values of the original dictionary, which is assign. Underscore tam. From this original dictionary we created earlier, we call its items method, which gives us a few of the key value pairs in this dictionary. Here we see them. A dictionary formed by two tuples, one with the key being the original ordinals, and the other with the values being the numbers we assigned earlier. Now we need to invert them, making the keys values and the values keys. To do this, we create a for loop that will iterate over each key value pair in the dictionary. K represents the original key, and Y represents the value associated with that key. Here with V colon K for K, we are working on dictionary comprehension compressions that we have dealt with in other videos. The curly braces indicate that a new dictionary is being created. The syntax V. Inside the curly braces, 2K establishes that for each iteration of the loop, the value of the original dictionary becomes the key of the new dictionary, and the key K becomes the value. This is where we carry out the inversion of the dictionary. Once we have the inverted dictionary, we simply pass it back to the pandas map method, which performs the new transformation. See you later. Now from numeric type to original ordinal categorical type, as we see in the output. Many datasets prepared for use in machine learning libraries may include class labels, especially for supervised learning tasks. But most of these libraries, as we have mentioned, require these labels to be encoded as numeric values. Most estimators used for classifications in scikit-learn already handle converting class labels to integers internally, but it is considered good practice to provide class labels already as integers to avoid technical issues. Their transformation can be done in a way very similar to mapping, the assignment of characteristics of ordinal values that we just did. But in general, and in this specific case, the class labels are not ordinal categorical data, but nominal. So it doesn't matter which whole number we assign to each label from the original string. So the number we assign will function more like an index. And we can simply list the class labels starting from 0. One way to convert class labels into numerical values is by using Python's standard enumerate function, which allows us to create index value pairs, which is what we need in this case for the class column of our data frame. We can analyze this line from right to left, which is the best way to understand these codes. With the numpy unique function, to which we pass the class column of our data frame as an argument, it gives us back an array with the unique values it finds in that column, which here will be class 1 and class 2. The result of calling this unique function is what we pass as an argument to the enumerate function, which takes any iterable as input. In this case, it's the array of unique values and returns an iterator of pairs, index value as mentioned. This way, we've now assigned a numerical value to each unique class label. Here, there are two, so they will be assigned 0 and 1. It's how enumerate works, assigning an automatic integer starting from 0 and incrementing by 1 for each element in the iterable. Now, sumanos on the far left of this code is where we perform a new dictionary comprehension almost identical to the previous example. What it does is iterate over each index value pair generated by the enumerate function and assign each unique class label its corresponding numerical index. The result is a dictionary where each class label maps to a unique integer. Class 1 to 0 and class 2 to 1, as we mentioned. Once the dictionary for assigning class labels into integers is created and stored in assignment class, we use the map method as in the previous example to transform the values in the etclass column from nominal to numerical. We can reverse the index value pairs exactly the same way we did with ordinal categorical values using dictionary comprehension. A for loop to iterate over and using the pandas map method to carry out the assignment with the inverted data. The process is identical, so no explanation is needed. The scikit-learn library also directly provides us with an alternative, using its label encoder class, which performs the same process of converting nominal categorical data into numerical data. Remember that now the column with class labels has its original values, nominal categorical. We create an object of the label encoder class and call its fit encoder method. Transform, which we already mentioned, is simply a shortcut that calls the fat and transform methods in succession, with the same result as before. We can also perform the key value inversion using the inverse transform method, which in this case transforms the class labels from integer values back to their original string representation.